sort of inform you of the direction we're taking in the school at the moment and the reasons why, and give you some strategies that you can use with your children at home as well. So you're working hand in hand with the teachers at home and you sort of understand what we're on about. So we're doing extended mathematical understanding program, which is a diocesan program, and we're working alongside Dr. Angela Soni, who's sort of guiding our school and many other schools in the diocese on approaches to teach mathematics. Alright, so we've started introducing the algorithm band within the school, and it was quite a big deal for the students. And the reason why we did, I'll give you some reasons why we have implemented this band. You're familiar with what an algorithm is? So if we're looking at this first question of 67 plus 56, and a lot of my work today will be on board, so if I get in the way or you can't see, just let me know. And if there's any questions as well throughout the session, feel free to ask, it's what we're here for. So an algorithm is when we write the sum up like this, and I'm sure this is probably how we were all taught, and probably the way we teach our kids as well. So if we did 7 plus 6, we'd go 13, carry the 1, I'd do 5 plus 6 is 11, plus the 1 more is 2, and I get 123. If I make any mistakes, feel free to point them out to me as well. So that's an algorithm, and we're trying to ban these within our school. Because if you notice what I said in doing this sum, I said 7 plus 6 equals 13, put down the 3, carry the 1, and then I said 6 plus 5 is 11, plus the extra 1 is 2. And this is where kids are starting to get a bit confused with the terminology here with this place value. That isn't a 6, it represents 60. And this isn't a 5, it represents 50. And this is where the children are becoming a bit confused with this. Another one, 20 times 5, so a lot of us do our multiplication like this, and we go 5 zeros, 0. It's probably not the best. 5 twos are 10. But it's not 5 twos, it's really 5 20s. If I change that and made it 24, same thing, 5 fours 20, put down the 2, put down the 0, carry the 2, 5 twos are 10, plus 2 more is 12. And I'm saying 12, but it's really 120. I'm saying 2, but it's really 20. I'm saying add the 2, but I'm really adding 20. So it's this language that the children are understanding, and it's confusing them. So we're looking at the quantity value versus column value. When I say 60 and 50, that's the quantity value, but when I'm just saying a 6 and a 5, that's the column value, and that's an area that's confusing the children. Another thing is that the children come to school with their own strategies for addition, subtraction, multiplication, division. And when we start introducing this to them, the strategies that they come with and that they've sort of developed or make up along the way through their education sort of get pushed to the side, not used, and they become very dependent on these strategies. And in our syllabus, it does say yes to introduce the children to the written algorithm, but only once the children have developed mental strategies and are competent and able to use mental strategies. A lot of times that part of the syllabus gets ignored about the mental strategies. People see, well, it says algorithms in the syllabus, we need to teach kids algorithms. But they need to be competent in the things that I'm going to show you today before they start doing this. And the algorithms are really only good for large numbers. Well, that's what we're only going to use them for in the school, is for large numbers. And a lot of the maths that we're doing doesn't require adding millions and tens of millions. So the need for it is really non-existent at the moment. Some of you may have participated in the survey that some of the Year 6 kids did, and this is just another reason why we are introducing this algorithm band. Quite a simple question, 13 plus 29, we asked the parents which child would they best want their child to be working at. Also asked what strategies which child would you think like. And a lot of parents actually chose the algorithm and said, this is the way I think, and this is the way I want my child to think. When ideally, we're looking at Jan as having the best strategy there. I know some different ways to do it the best ways in my head. So there's many different strategies I can take, but I can do that in my head. Mr. Marnie and I also did a similar survey with many of the Year 6, not many of the Year 6 kids, a handful of our top Year 6 kids and a range of kids from Year 3, Year 4 and Year 5. The question was 99 plus 24, I think. And 99 plus 24 is quite an easy sum to do. But most of our top Year 6 kids chose an algorithm to do 99 plus 24, which is really a sum that they should be able to spit out in no time at all, but rely upon doing it this way. And in the Years 3 and 4, a lot of them chose this strategy as well. So in that survey, we discovered that the kids are very dependent on this. Some more examples of the reasons why we're introducing this ban is NAPLAN this year. I was just roaming around looking at some of the kids doing their work. One of these questions came up. Mary has some packets of buttons and 2 extra buttons. How many buttons does Mary have in total? I'll give you a second to just work it out. Think about the strategy you do. Got an answer?
42.
42. How long did that take? 5 seconds to really think. This is a strategy one of the children took and wrote down. Had to write 10 plus 10 equals 20. 20 plus 10 equals 30. 30 plus 10, because the only way that they could add was with the algorithm. That took them at least a minute to do that process. Another example, it's a bit blurry. Leah travelled 14 kilometres by bus and then 67 kilometres by train. How many kilometres did you travel altogether? Mm. 71, not a bad answer, but when we look at the approach, algorithm 7 plus 4, did the right process, but when adding, forgot this one. So it had 71, and if you look at the answers, the correct answer was 81, and they put 71 in there for those kids that can't do the algorithm strategy properly. And the research shows that a lot of children that do algorithms can't see their errors, whereas the kids that use mental strategies and informal ways of recording are able to identify their errors more often. So they are sort of the reasons why we've introduced this algorithm ban within the school. And today, what I'm going to try and show you are the strategies that we are working on with your children. So you can take them home and sort of, if they ever get stuck, work with them. The simple one, friends of 10 for addition. So we'll do some addition. A lot of the work's going to be here on the board. And you have it there in front of you as well to take home. But friends of 10 is probably the most basic strategy that the kids need to understand, and this starts in kindergarten, and it is still used. This is something that I still use when I do my mental strategies. If we don't have this basic understanding of the friends of 10 concept, or rainbow numbers as they're sometimes called, it makes mental addition very challenging. So if you look on your little handout, we've got the little rainbow there, and it just shows how 7 and 3 go together to make 10, 2 and 8 go together. And then that comes up with large numbers, say 15 plus 6. Well, I know that 15 plus 5, well 5 and 5 is going to give me that 10. So I get that 25, and then plus that extra 1 to get the 21. Yes, that's right. Starting on the first one, that's not cool. The next one's doubles. So the next step that we sort of introduce the kids to after they've got that friends of 10 concept is doubling. And so as you can see there, 4 plus 4 is 8, so getting the kids to have these basic facts and then being able to apply them once larger numbers come up. I don't have it, oops. And then we can also step into near doubles, which is on the piece of paper I think.
Yep. So
having 4 plus 5, I know that 4 and 4 is 8, plus that extra 1 is going to give me 9. So that's called near doubles, and it does require the kids to have those mental strategies and understanding of number, which comes with a lot of practice. So having tens facts, and this is pretty much just skip counting, and this is also a strategy that we will be using in kindergarten and year one, and a lot of people might think, oh geez, kindergarten? Are you serious? But no, this is what we are aiming for with kindergarten, definitely year one, this sort of level of thinking. More towards the end of kindergarten, obviously, not straight away. But to do the 37 plus 52, you know, I can use my fingers to go count by 10, so just to keep track of my recording. 37, 47, 57, 67, 77, and then that 2 extra is, I've lost track, 79. So that's using those tens facts of jumping down the number chart here and recognising that I can count by tens and add that way. A lot easier than having to write 37 plus 52. Next one is the split strategy. This is probably the most common strategy for a lot of kids to use. 24 plus 35. Now you might say this is very similar to algorithms, but what it's doing here is looking at the quantity value rather than the column value. So I'm going to take the 2 and the 3, but not call it 2 and 3, and call it 20 plus 30, which is going to give me the 50, and then do the 4 and the 5, which is going to give me the 9, which I can then add together to give you the 59. Probably the most common strategy for the kids to use. And probably one of the easiest, because it does allow for when we do have that trading. So if we had something like 68 plus 24, I'm doing the 60 and the 20, which equals the 80, and then I've got the 8 and 4, which equals the 12, but then I can add those and get the 92. So I'm not having any problems with that trading. If I'm going too fast or you have any questions, just call them out. Compensation. Now that concept map that I showed you before, and the one that we gave the year 6 kids and the year 3 and year 4 and year 5 kids, 99 plus 24, all they need to do is use the compensation strategy for this. 99 is very close to 100. So to make it 100, I just have to add the 1 to there. So now I can do 100 plus 24 easy. 124, take away that extra 1 that I added on, I'm going to get 123. So there was no need for them to write an algorithm. It's something that they should be able to do quite quickly in their head. 49 plus 28 on the sheet, I showed you 2 ways. That can be very close to 50. So I can go 50 plus 28 equals 78, take away that extra 1 that I put on to get 77. Or leave it as 49, and it depends on what you're more comfortable with. You might be comfortable working with 50 and adding the 28, or you might go, well, I'm going to change that to 30, and I can do 49 plus 30 equals 79, take away the extra 2 that I added on to get the 77. You are able to see? So that's called the compensation strategy. And the trick with having all of these strategies is knowing which one to apply for which question. So when we're very, very close, you could even be, if it was 41 plus 28, I could take away that 1 and then add it back on later. So it's knowing which one's going to work best for you for that question. I do have near doubles, so that's going back up to this concept here. I can go 25 is very close to 27. And I know my number facts that 25 and 25 is 50, plus that extra 2 is going to give me 52. So it's being able to see these patterns in the numbers as well. And this is where we start getting into year 2, year 3 sort of thinking here. This is what we're aiming for within the classroom. And then finally, blank number lines, and these are the best way to sort of demonstrate or allow the children to demonstrate their thinking. So if we have 37 plus 21, a lot of these, if it's not working out, I'd say draw a blank number line, and I'm saying this all the time in the classrooms that I'm visiting at the moment. It's the easiest way to do it. So if we have, the easiest way for the children to record their thinking.
Yeah.
So if we have 37 and it's just a blank number line, I'm not having 1, 2, 3, 4, 5 and drawing on. I can start at any number, finish at any number, do as many jumps as I want in whatever way. So plus the 10, so it's like doing the tens facts. Add 10, so I'm going to get 37, 47, 57, what was my number, 21, plus the 1, and I get the 58. If my child did that I was working with, I'd say, can you do it a faster way? Can you see something else? They might go, well, I know the 20, and I can do that straight to 57 jump. They might want to add the 1 first, and go, right, I can do the 1, which is going to be 38, and then I know I just have 20 to go to get me to 58. So this is just a way for the children to represent their thinking, and it's a good strategy to use at the beginning as well, so that they can see what they are doing. And then we have informal recording. So we're starting to get into the bigger numbers, 3-digit and 3-digit. And for this one, it goes back to the place value rather than the column value. So it may look like an algorithm, but what I'm doing is saying 100 plus 500 is 400. 20 plus 10 is 30. 7 plus 8 is 15 to get 445. Very, very similar to algorithms, but I'm not getting confused with any trading. And I can see the value of these numbers. So I have a little break. That's addition. Any questions for addition? Am I moving too fast? It's all pretty easy. We're adults, we're very clever people. But for kids, these are the strategies we're trying to introduce to them and get them thinking about. These start to get a bit tricky with subtraction though. A lot of it is the same as addition. They go hand in hand. So friends of 10 applies with the subtraction as well, and if those kids have base understanding of their friends of 10, it makes everything a lot easier. So just doing 20 take away 8, I know that 2 goes with 8, so it's going to be 12. So knowing what number goes with 8, what number goes with 3, what number goes with 6. I think I'll put an easy one on your piece of paper. Commutativity, that's a big word. We don't really say that word to the kids. This is teacher talk. Now it's parent-teacher talk and parent talk as well, so you sound very professional using this language. Commutativity is basically making it easier for yourself. Because I suck at doing subtraction, I don't enjoy doing subtraction, so I'm going to turn this into an addition problem which I'm much more comfortable with. So I can go 24 plus something equals 33. Now I just need to work out what that something is. I think on the handout I just used the blank number line to get me there. So I could go, or I could use my tens facts and go, right, well 24 plus 6 is going to give me to the 30, which I'm comfortable at working at, and then that extra 3 is going to get me to 33, so my answer is going to be 9, which I then bring up here as being 9. I'm a lot more comfortable doing addition than subtraction, so this is me personally, I turn any subtraction question I have into an addition one. Near doubles applies, it's sort of halving instead of doubling. So I know that 6 and 6 makes 12. So if I just take away 1 away from that, I'm going to get the 5. So applying the near doubles and understanding doubles into subtraction. Split strategy once again, probably one of the easiest ways. Until we get to trading, then it doesn't really work when your one's column, one's number is larger than this end. That's when it gets tricky, and that's when I would say, well, this split strategy, I'll show you. So 80 take away 40 equals 40. 8 take away 2 equals 6. So my answer is going to be 46. Yes. Now if that was, say, 9 and this was a 3, this is where this strategy might not be the best one. So if I give 80 take away 40, I get the 40 again, but I can't go 3 take away 9. I can't make that go, well, I can't do 3 take away 9, so I'm going to make that 9 take away 3. You're just totally changing the sum there. So in this situation, I'll go, right, this strategy is not the best one for me. I might do the informal number line, I might do commutativity and change it into addition. Compensation once again, and this one throws me a little bit, but 49 is very close to 50. I was practicing this at home last night, and you know, if the kids found out at school that I was stuck on this, it would be like, oh no. So you have to keep my secret here. Football was on, I was just going through making sure I had all my numbers right, and I thought I'm going to practice this one because I always get stuck. So, and I'll show you why. Let me write the sum up like this. And this is, I'll just show you another strategy that you can use with the kids. So my 49 take away 28. Now obviously compensation probably wouldn't be the best one for this. I can just go split strategy on it. You go 40 take away 29 take away 8. I'll show you the other thinking as well. If I try to make this 50, I have to add 1 onto that. And then 50 take away 28 is going to give me the 22. No, I'm confusing myself here. That wasn't the one I was doing. See, it throws in this strategy. I did 49, I made this 30. So I add 2 onto that to make it 30. So then I do 49 take away 30 is 19. And then I think because I added 2 here, I need to take away 2 here. That sounds right, doesn't it? If I add 2 on there, I have to take away 2. But I'm getting the answer 17. And when I look at this, I know, and this is where being a good mathematician comes in, and looking at these strategies, I know that doesn't seem right. So I'm sitting at home on the football trying to work out what's going on. And this is the thing that I say to all of the kids, draw a picture. Chelsea will vouch for that, because yesterday, year 6, we were doing some maths, I said draw a picture, and it all suddenly appeared. So my picture might not make sense to you, but it makes sense to me. There's my total, and I'm pretending that there's 49 counters in there. I'm going to take away, this is roughly, about 30 of them. I only need to take away 28, but I need to take away 30. So I'm going to add 2 more into here. So if I take away the 30 from there, I'm going to have 19 left in here. But the 2 that I took away from in here, I have to add into this pile again. So it's not taking away, I'm adding them back in. So it's going to be 21, not 17. It's confusing. I wouldn't use this strategy though for this question. And very rarely would we use the compensation one. But I just threw it in there anyway and just showed you when I say draw a picture, I'm not drawing a picture, sort of picture. It's just representing my thinking in a different way. Blank number lines once again. So for subtraction, this is the one I like to use. Either the split strategy, if that's not going to work for me, I get the blank number lines out. So take away 45. For this one, I'm going to take away the 1 because I work better in tens. So if I'm doing 81, take away 45, I'm just going to write that there so I remember. 45, if I take away the 1, I'm going to be on the 80. So now I just have 44. I can take away 40 from that. So I'm going to be on the 40, and then I just have the 4 to take away. And because I know my tens facts, there's 2 examples of tens facts here. I know that 4 will then has to be 6. It's going to be 36. And I have no problem with Year 6 kids drawing a blank number line if they need to express their thinking. We're introducing it into Year 1, and it's definitely something that can be used all the way through. And then our informal recording, same as what we had for the addition. I'm not going to say 5. We usually start here and go 8 take away 7. Can't 1 take away 2. Can't do. Remember this? This is the way some people do it. Okay, so I'm going to get rid of all of this mumbo jumbo and just go right. Oh, okay. All right. I see what I've done here. I remember. I did it purposely for the trading. Different strategies, different ways you can approach this. And I go 500 take away 100 is going to be 400. Got a problem, but I can't do 10 take away 20. I can't even go 18 take away 20. So I'm going to start again. I'm going to do, keep up with me, but this is my thinking. Strategies, not just one formulated way, everybody do this. Now here's a list of questions. Sit down in your book, shut up and do it for half an hour and get your calculator out and check that you've got them all right. We don't want that. We want to expose kids to many different ways of thinking. So bear with me, let's see what we can come up with. I can go 500 take away 20. So this is where the place value comes in. I'm going to do the 500 take away the 20. It's going to give me 480. So I've taken away the 20. Now I'm going to take away the 100, which is going to give me the 380. And now I just have the 7. 10 facts comes back into it. I'm going to have 373. That's not right, is it? No. What did I do?
Yeah, 18.
18. Add the 18 because I didn't do the 18. Alright, start again. You see that didn't work out. What did I do? Does anyone else have a strategy they want to show me? So I'll try again. I might do the 518 just to keep it simple and take away the 20. So I know that's going to be 498. Take away the 100, 398. Take away the 7, 391. That looks a bit better. But do you see how I could tell that that wasn't right? So when we go back to that very first bit at the beginning, an algorithm kid, they just stuff up one little bit of the trading. They don't recognise it, whereas I could recognise something was not right there and I could fix it up. But maybe for that question I might go, oh, the blank number line. I might check my answer by doing the blank number line. The fun one, multiplication. Try and get through it very, very quickly. Arrays. Arrays are what we do to introduce kids to multiplication now. We try to avoid having your multiplication test at the end of every week. Okay, this week kids, we're all learning our 3 times tables. Go home, write out your 3 times tables 100 times. We're going to give you a test at the end of the week. And you rote learning. There's nothing wrong with that. Fantastic. If you kids are going to learn their multiplication facts that way, fine. But do they understand what these numbers all represent? If I said 9 times 8 and they go 72, right, what am I really asking you though? You know this combination of numbers, but do you know what it represents? So in the early years, we represent our multiplication with arrays. And if you have a look on the piece of paper on the reverse side, there's a quick example of an array. So we use the counters for those. And even a simple one like 3 times 4, if you can picture what you've got there, I can use my number factors of 3 times 4. I could double that array and visualize it, that if I have a 3 times 4 one with my dots, and then I give you the sum of 6 rows of 4, I just have to double that to get my 6 times 4. So the arrays are very useful, especially if your child is having any trouble with multiplication. Having it visual representation there for them will help them to understand what it represents. And then once they get older and have that understanding, they'll visualize that in their mind when given a multiplication. They'll see the array and know what to do with it. So seeing that array will help me with my skip counting. If I can see 8 rows and 5 columns, I know that I can count 5, 10, 15, 20, 25, 30, 35, 40. I can do 8, 16, 20, 32, 40, 48. Yeah, that's right. So I'm seeing that array in my head as I'm counting it. Informal recordings, now this is one of my favourites, because everyone goes, alright, well what about when we have the large numbers? How are we supposed to do this in our head, Mr. Boyer? What are we supposed to do with this? It's very easy. If you've had a sneak peek on the sheet, it's like split strategy for multiplication. I can split that up into 20 and 2, and I can split this up into 10 and 5. Now all I have to do is just some really simple multiplication. 20 times 10 is 200. And this is for the kids that understand their facts. I'm not going to give this to year 1 kids they work out when they don't have their understanding of basic multiplication. 20 times 5 is 100. 2 times 10 is 20. 2 times 5 is 10. I just have to add all of that up now and I get 330. Any other day of the week I gave that to you and asked you to work that out in your head, people are going, wait a minute, no, I need to write this down. But it is something that we can do quite easy. I might look at that completely different and just go 22 times 10 is 220. And now multiply by 5. I've got a strategy for multiplying by 5. I multiply by 10 and halve it. If you think of your array of 5 times 10. So if you visualize 5, 5, 5, 5, 5, 10 times, halve that, I've got 5 and 5. So if I multiply by 10 and halve it, I'm going to be able to multiply anything by 5 just by multiplying by 10 and halving it. So if I multiply this by 10 and half, that's 110. So I'm going to get 330. So it's having these different strategies to use. And this is where these are things that I'm trying to introduce to the older kids when I was teaching primary, upper primary. So if you multiply by 2, just double it. Think of that array. 24 there, double 24, I'm going to get 48. If something's multiplied by 3, so if I have 6 times 3, think of that array of 6 times 2. Well, I know my 6 times 2s. So I double it, and then just add one more row of 6. So if we got into bigger numbers of 16 times 3, I can double 16, which is 32. Add another 16 onto that. So I write it there so I can see it. I use my split strategy. 30 plus 10 is 48. I've just done 16 times 3 in my head without doing any multiplication. Basically what I did was the jump strategy. What was it? Skip counting. 16, 16, 16. You do not need to know your multiplication facts to do multiplication. That's why having that test at the end of the week, knowing all of your facts, it's really pointless. You don't need it. Times by 4, just double. I just write 31, 31. So that's 2 times. It's going to get me 62. Double that again. It's going to get me 124. And that's for any number, times by 4, just double. Sound familiar, girls? That strategy of times by 5, times by 10, then halve it. So if I had 54 times 5, we'd have to get this out and do 5 times 4 equals 20, 5 times 5 is 25, plus the 2, 27, okay, 540, half 500, 250, half 40, 20, get to 270. No multiplication needed to do multiplication. Times by 6, I do my times by 5 strategy, so if I have that, what did we have? What was our answer? 240? I just have to add another 54 if I'm timesing by 6. I'm going to have 294. So I just do times by 5 because that's an easy one that I can do, and then add that extra. So it's these things that we're trying to introduce to the kids, and then times by 8, double, double, double. So having these strategies, quick and easy ways of doing them, addition, multiplication, subtraction. One is helping them understand what they're actually doing, understanding that value of the numbers that are there in front of them, and hopefully minimising any mistakes and allowing them to see their errors a lot faster. So that's it, and I do appreciate you coming, and if there's any questions, now's the time. If you're a bit embarrassed to ask questions and you want to ask me privately, that's fine. If you didn't get something, I'm happy to go through it with you. But yeah, thank you very much for coming. These are the things that we're doing in the classroom, so if your child comes home with any questions or errors, please have a look to that sheet and feel free to help them out. And if they get stuck, send them to me. I love doing the maths, so I'm always keen to help kids out. So, any questions? No? Terrific. If you came in late and you want me to run through just the beginning part, I'm more than happy to do that. But thank you for your time today, and if you want to come back again, we're doing it again at 2:30. You might not make as many mistakes next time. But thank you, everyone.